Today we're going to learn how to graph quadratics from intercept form. So intercept form is the same thing as factored form. It's just what we get after we do the box and diamond or greatest common factor to something that was in standard form. So for example, we've got this problem here, y equals 2 times x plus 1 times x plus 2. This form, factored form, is the third type of quadratic that we've learned. Before this, we knew vertex form, which is the a times x minus h squared plus k, and standard form, ax squared plus bx plus c. So let's go ahead and graph it. So here we have a very simple factored form of a quadratic, x minus 1 and x plus 3. We are in the habit of solving quadratics, and that's where we have 0 equal to our equation. Now hopefully you guys know, at this point, to solve it, we just set each factor equal to 0 and solve them individually. So if we do that, we get x equals 1 and x equals negative 3. These are the intercepts of our parabola. So we can go ahead and graph x equals 1 and x equals negative 3. Now 2 points is not enough to draw an accurate parabola. We also need to find our y-intercept. Now hopefully you remember from last semester the way to find a y-intercept is to set x to 0 and solve for y. So let's do that in our equation. So I would write y equals 0 minus 1 times 0 plus 3. Now 0 minus 1 gives me a negative 1. 0 plus 3 gives me a 3. When I multiply, I get negative 3 for my y value. So I can plot that on my graph. Now remember, a quadratic is a perfectly symmetrical u, so we need to draw a perfectly symmetrical u through these 3 points. Keep in mind that your y-intercept will very rarely be your vertex. So if I do my best at drawing a perfectly symmetrical u, I would say it looks something like this. Okay, so take a second, pause the video, and write down these steps. Number 1, find the x-intercept. Number 2, find the y-intercept. If those don't work, make a table. That's always going to be our backup. Step 4, which I don't have on here, graph a perfect u. All right, let's do a little bit more challenging of a problem. So just like before, we're going to find our x values. We're going to solve for our x-intercepts by saying 0 equals our equation. Okay, to solve, we know we set each factor equal to 0 and solve them individually. So we get x equals negative 4 and x equals negative 1. So I'm going to plot those on my graph, negative 4, negative 1. Now my next step is to find my y-intercept by setting x to 0. So I'm going to say y equals negative 2 times 0 plus 4 times 0 plus 1, which gives me y equals negative 2 times 4 times 1, so y equals negative 8. So I'm going to plot that on my graph somewhere about right here. Now this one looks a little bit challenging. A lot of people are going to want to draw their u something like this. Is that a perfectly symmetrical u though? The answer is no, of course it's not. So we need to get creative with our u. Now one thing to notice is at the front of our equation, we have this guy. That number out front is always going to be our a value. And if you remember from the lesson on graphing from vertex form, our a value tells us if it's fat or skinny, and if it flips. So if we notice this negative here on the 2, we should know that our parabola is going to be an upside down u. So that gives us a hint that maybe our u looks something like this. Okay, so remember that the vertex can be outside of your x-intercepts. The important thing is that your u is always perfectly symmetrical. All right, so if you think you know what you're doing, go ahead and pause the video and give this problem a shot. Remember, our first step is to solve for x. So we set y equal to 0 and solve by setting each of our factors equal to 0. So here we're going to divide by 1/2, or, if you're clever, multiply by 2, and I still get x equals 0. And here I get x equals -6. So let's go ahead and plot those two. We have 0 and we have -6. The next step is to find the y-intercept. Okay, for the y-intercept we set x to 0. So y equals 1/2 times 0 times 0 plus 6. So I get y equals 1/2 times 0 times 6. Then I get y equals 0, which we already have plotted. Now, like I said 2 slides ago, having 2 points is not enough to graph a quadratic. So like we said on the previous slide, if this doesn't work, we can make a table. Okay? But our table's going to be very simple. In my table, I need an x and a y, and I just have to pick an x between my two x-intercepts. So for this problem, I'm going to choose -3. I feel like it. I could have picked -2, -1, 4, or -4 or -5, but I chose -3. Now to fill in a table, all you do is plug in this x value to your equation. So I'm going to write y equals 1/2 times -3 times -3 plus 6. So if I multiply, I get -3 plus 6 gives me a 3. Okay, now it's easier to multiply whole numbers, so I'm going to say -3 times 3 is -9. And 1/2 of -9 is -4.5. Okay, so fill that into your table, -4.5, and then plot the point x comma y. So on my graph, I'm going to go to -3, then I'm going to go down 4.5 to right here, and I'm going to graph my quadratic. Now, luckily for me, -3 is exactly halfway between my two x-intercepts, so I know that is, in fact, my vertex. So there's my u. All right, this is going to be our last example. You'll notice that this is written in standard form, y equals ax squared plus bx plus c. So what I need to do here is actually factor to find my roots.
Could you please come to the main office, Tucker Maholka?
All right, so quick refresher of the box of diamond. First term, first box. Last term, last box. Multiply these two together to get the top of my diamond, and put the middle term in the bottom. Now I need two things that multiply to -2 and add to -1, which are -2x and 1x. Those two guys move into the box, and then I fill in my sides. So I know x squared is x times x. X times 1 gives me 1x. X times -2 gives me -2x. So I have x minus 2 times x plus 1. And now I'm ready to graph from factored form. So go ahead and pause the video and try this out yourself. All right, step 1, we need to solve for x. So here I get x equals 2. Here I get x equals -1. So let's go ahead and graph those. Now I need to find my y-intercept by setting x to 0. So y equals 0 minus 2 times 0 plus 1. -2 times 1 is -2, so that's my y-intercept. Now I'm ready to graph my parabola. So that wraps up our lesson on graphing from factored form or graphing from intercept form. So go ahead and try these two problems. Be ready to turn them in class.